Good afternoon, Rich Nass, Open Systems Media, and I'm here in the BeagleBone booth. I'm here with Jason Kridner, and he is the, what is your official title?
I'm a co-founder and board member of BeagleBoard.org.
There you go. I just think of you the god of BeagleBoard, but that works. But we've always associated the BeagleBoard with lots of typical applications that the Maker community uses, the Maker Pro uses. But from what I understand, we're moving into a much more expansive area with robotics. Is that true?
Absolutely. So we think that robotics is really the gateway drug for a lot of new people to get into our industry, to kind of understand what electrical engineering, computer science, building embedded systems is all about, right? So we think that's the kind of the new gateway drug, and we want to be there as a provider.
And what's the starting point? What's your starting drug?
So the new entry here is the BeagleBone Blue, right? So that's this board here. And it's everything you need to control a robot. So it's a 1 gigahertz Linux computer with Wi-Fi acting as an access point, doesn't connect up to your networks, and Bluetooth low energy, all built in, and everything that you need for building a mobile robot, right? It's got the motor drivers built in, it's got servo drivers built in, the ability to drive ESCs for quad, hex, and octocopters, right? We've got integration with projects like RGPilot. So RGPilot is an open source autopilot, and you can take that and build your own quadcopter, give it waypoints, have it auto land, fly it to GPS locations. We've got the sensors built in. We've got the accelerometer, gyroscope, compass, barometer, temperature sensors. So all the sensors are already built into the board. Everything that you need to build a flight system is already here. It's all integrated with software. It's ready to go.
And then from a software perspective, what does somebody need to do to package it all together?
So the typical developer, right? So for a traditional embedded systems developer, I think C is still the language for building systems. So we provide a C library called libRobotics Cape that was developed in conjunction with the University of California, San Diego. They've already had hundreds of students build robots in their labs, building work with the BeagleBone, the original BeagleBone Black, and a cape that they had. So we've now combined all those into one and added the Wi-Fi and Bluetooth. We're also using the Octavo SIP to make a much simpler board design, right? So I don't want to go too far down that, but this is a really easy board for people to take and fork and build their own hardware out of. But for a programmer, right, that C API gives them a known starting point, right? So we have a built-in web server. We got a 4 gigabyte flash on here with the Linux distribution Debian on there with the web IDE. They simply point their web browser to the board, logging into its access point, and they could just run the existing applications that are already pre-built, all written in C, to test the motors, to test the sensors, right, to read back the wheel encoders, right? So there's already pre-built app and C examples for all that compiled into a C library, and of course then we're working on bindings in other languages. We've also, it's also possible to run LabVIEW on the BeagleBone Black and the BeagleBone Blue as well, and so we can actually connect up LabVIEW to that C API, and we actually can build all these applications and demo applications using that. So you don't have to be a programmer to be doing development on the BeagleBone Blue.
Very impressive. So if somebody wants more information, where do they go?
BeagleBoard.org/blue.
BeagleBoard.org/blue. That's it.